Welcome to Vibratech Trainers and Consultant Private Limited. We are going to see an interesting bearing failure case study on blower. This is applicable for all types of industrial blowers. Case study prepared by Vijayakrishnan Venugopal, Director of Vibratech Trainers and Consultants Private Limited, Chennai. He is a chartered engineer with more than 35 years of experience. He is an international vibration consultant and ISO certified vibration analyst Cat 3 certificate holder. Also, he is certified maintenance and reliability professional from SMRP. Blower we are going to see is belt driven by a motor of 55 kilowatts, operating speed 2865 rpm with anti-friction bearings. The blower is mounted on steel frame on concrete floor at ground level without any anti-vibration mountings. Vibration measurements are taken in all three directions: horizontal, vertical, axial, in each locations. Measurement locations are motor non-drive end bearing, motor drive end bearing, blower drive end bearing, blower non-drive end bearing. Vibration data are collected in terms of displacement in microns peak to peak and velocity in millimeters per second RMS. Now onto the vibration limits. As per ISO standard, and with our previous experience, when the velocity falls below 4.5 mm per second RMS it's considered as good. When the velocity falls between 4.5 to 11.0 mm per second RMS it is considered as fair. And when the velocity falls above 11.0 mm per second RMS it is considered to be rough. It is found that vibration levels indicating increasing pattern with fluctuations or amplifications in the blower bearings. The blower was taken for detailed analysis. Before rectification, vibration data are collected. The vibration values are maximum at motor non-drive end axle, velocity up to 10.3 mm per second RMS with displacement of 55 to 150 microns peak to peak. The vibration values are maximum at blower non-drive end vertical, velocity up to 13.3 mm per second RMS and displacement of 53 microns peak to peak. And the equipment falls under rough category. Going through the spectrum and frequencies at blower, driven end dominant peak frequencies are in higher frequencies indicates bearing inaccuracies. And frequencies at blower non-driven end dominant peak frequencies are in higher frequencies. That also indicates bearing inaccuracies. The frequency of the equipment equals the ball pass in a race frequency multiplied by operating speed with its harmonics, and ball spin frequency multiplied by operating speed with its harmonics, and also that bearing condition values are high in all three directions. Inaccuracies in both blowers' bearings were suspected. Phase analysis revealed an erratic phase in all three directions. The blower bearings were inspected, and severe damages in roller and in a race were found, and therefore the blower bearings were changed with new ones. The picture shows defect in bearing in a race. After the rectification work, vibration data are collected. The vibration values are maximum at motor drive end horizontal, velocity up to 2.6 mm per second RMS and displacement of 16 microns peak to peak. The vibration values are maximum at blower drive end vertical, velocity up to 2.5 mm per second RMS and displacement of 18 microns peak to peak. And the equipment improved to good category. The comparison spectrums of blower drive end vertical. The spectrums shows the first peak frequency velocity value is reduced from 5.53 mm per second RMS to 2.21 mm per second RMS. The comparison spectrums of blower non-drive end vertical. The spectrums shows the first peak frequency velocity value is reduced from 6.24 mm per second RMS to 0.96 mm per second RMS. The reduction in vibration levels in blower non-drive end vertical from 39 microns and 13.3 mm per second to 9 microns and 1.9 mm per second. After bearing replacement, significant reduction in vibration levels are indicated at all locations and the blower is running normally. The health condition of the blower was improved from rough to good category. Vibratech cater among all major industrial sectors. We conduct vibration analysis level 1 and 2 training programs online and also in plant. ISO Certified Vibration Analyst Category 1, Category 2, Category 3 Training and Examination. Services we provide are vibration analysis, in situ dynamic balancing, laser alignment, motor current signature analysis, thermography, building or ground vibration measurements. We also market and provide service for machinery vibration analyzers and meters, and low frequency building vibration analyzers.